Welcome students. Today we will discuss a topic isotopes and isobars from the chapter structure class 9 chapter 4 AZIDO Academy Education. Please like, share and subscribe the channel. Don't forget to click the bell icon so that I can send you notification for every video. Contents of structure of the atom. Number 1, what is an isotopes? How does an isotope form? What are the three examples of isotopes? Why are atomic mass of most of the elements fractional? Why is the atomic mass of chlorine taken as 35.5 U? Number 6, properties of isotopes. Number 7, physical and chemical properties. 8, types of isotopes. Number 9, what are the application of isotopes? 10, special properties. 11, who discovered isotopes? 12, why do isotopes exist? 13, what are the natural isotopes? 14, how are isotopes useful? 15, what is radioisotopes? 16, what are isobars? 17, what are the characteristics of isobars? 18, what are difference between isotopes and isobars? And the last one is 19, short question and solved. All the topics are explained thoroughly, very carefully and clearly. Still, if any single student is unable to understand any part of the video, please let me know in the comment box. Now, what is an isotope in chemistry? Isotopes are atoms of the same elements that have different numbers of neutrons but the same number of protons and electrons. The difference in the number of neutrons between the various isotopes of an element means that the various isotopes have different masses. Now the next, how does an isotopes form? Isotopes can either form spontaneously, naturally, through radioactive decay of a nucleus, that is emission of energy in the form of alpha particles, beta particles and neutrons and protons, or artificially by bombarding a stable nucleus with charged particle by accelerator or neutrons in the nuclear reactor. Now look at the screen. There is a two picture of the isotopes of hydrogen and carbon. Now the hydrogen. Now this is the hydrogen isotopes of hydrogen. Hydrogen 1 means there is only one atomic mass and atomic number. It's called protium. Second, deuterium. Its mass number 2 means mass number 2. And the third one is the mass hydrosium 3 tritium, mass number 3, means atomic number it's 1, proton also 1, but the first one is 1 proton 1 electron, so that's mass number also 1 and atomic number also 1. Second is deuterium. Deuterium its mass number 2, means 1 proton 1 neutron. And third one is hydrogen 3 tritium. It's a 1 proton and 2 neutron. Just like isotopes of carbon, carbon have 3 isotopes: carbon 12, carbon 13 and carbon 14. Now, what are 3 examples of isotopes? The number of nucleons, both protons and neutrons, in the nucleus, in the atom's mass number, and each isotope of a given element has a different mass number. For examples, carbon 12, carbon 13, carbon 14, and 3 isotopes of the elements carbon with mass number 12, 13 and 14 respectively. Kind attention all students, watch the video carefully and repeatedly to understand properly. Stay tuned for all video updates. Please comment in the comment box for all your doubts in this chapter. I will make video for all questions raised by students. Please don't skip the video, otherwise you will miss the important part. Now the next, why are atomic masses of most of the elements fractional? The atomic masses of most elements are fractional because they exist as a mixture of isotopes of different masses. Elaborate. Most elements occur as a mixture of isotopes of different masses. The fractional atomic masses rise because of this mixture. Average mass is equal to total mass of all atoms by number of atoms. So before we calculate the average masses of atom, let's use an analogy. Assume that a class contains 10 boys, its mass 60 kg, and 20 girls have mass 55 kgs. What is the average mass of the students? Mass of boys 600 kgs. Why? Because 10 into 60 is equal to 600 kgs. Mass of girls 11, 20 into 55 so is equal to 1100 kgs. Total mass of students is equal to 1700 kgs because 600 plus 1100 is equal to 1700 kgs. Now the average mass of one students 1700 kgs by 30 students is equal to 56.7 kgs by student. 56.7 kg by student. Now the next question, why is atomic mass of chlorine taken as 35.5 U and not a whole number like 35 U or 36 U? Explain. Answer. The reason for the atomic mass of chlorine taken as 35.5 U and not an 35 U because of the presence of isotopes. Isotopes are defined as variants of a particular element where these variants will have the same number of protons but different in the number of neutrons in the atom. The definition of isotopes: elements have same atomic number but the different mass number. So that consider a chlorine atom, it will have 17 protons and has two isotopes that are chlorine 35 and chlorine 37. Now chlorine 35, a number of protons are 17 and the number of neutrons are 18. It happens in nature about 75% of the time. Means chlorine 35, it's about 75% of the time in nature. Chlorine 37, a number of protons are 17 but the number of neutrons are 20. It happens in nature about 25% in the time. Means chlorine 37 isotopes are found in nature about 25% of the time. Atomic mass in an atom or group of an atom in the sum of the masses of protons, neutrons and electrons. For an element, relative atomic mass is the average mass of the naturally occurring isotopes of that element relative of the mass of an atom of carbon 12. So now relative atomic masses, this is the calculation or numerical. The first one is chlorine 35, its percentage 75%. So that's why 75 by 100 into 35. Plus second one is chlorine 37, its percentage is 25. That's why 25 into 37 by 100. So after calculation, it will be relative atomic mass is 35.5 U. Thus, the atomic mass of chlorine is taken as 35.5 U and not a whole number like 36 U or U. Now, properties of isotopes. Key points. Isotopes are atoms of the same element that contain an identical number of protons but a different number of neutrons. Despite having different numbers of neutrons, isotopes of the same element have very similar physical properties. Some isotopes are unstable and will undergo radioactive decay to become other elements. The predictable half-life of different decaying isotopes allows scientists to date material based on its isotopic composition, such as with carbon 14 dating. Terms: any isotope of two or more forms of an element where the atoms have the same number of protons but a different number of neutrons within their nucleus. Half-life: the time it takes for half of the original concentration of an isotope to decay back to its more stable form. Radioactive isotopes: atom with an unstable nucleus characterized excess energy available that undergoes radioactive decay and creates most commonly gamma rays, alpha or beta particles. Radiocarbon dating: determining the age of an object by comparing the ratio of the carbon 14 concentration found in it to the amount of carbon 14 in the atmosphere. Physical and chemical properties of isotopes. When we talk about the chemical properties of isotopes of a given element, they are almost of same or identical. Different isotopes exhibit nearly identical chemical behaviors. However, when it comes to physical properties of isotopes like the mass, melting or boiling point, density, and the freezing point, they all are different. The physical properties of any isotope mostly depend on the mass of each isotope. Knowing the differences allow us to distinguish between one isotopes from another. Types of isotopes. Isotopes are said to be either stable or radioactive. Therefore, isotopes that are radioactive are often called as radioisotopes or radionuclides. Isotopes that do not decay radioactively are known as stable isotopes or stable nuclides. As per the finding, there are about 339 naturally occurring nuclides or isotopes on the planet Earth. In this, 286 are said to be perimordial nuclides, which are believed to have existed since the formation of the solar system. Next, What are the application of isotopes? First, an important application of isotopes is in the determination of the isotopic signature of element samples via isotope analysis. This is generally done via the process of isotope ratio mass spectrometry. Second, the mechanism of a chemical reaction can be determined with the help of isotopic substitutions. The change in the reaction rate can be measured based on the kinetic isotope effect. Third, isotopes can also be used to determine the concentration of many elements, substances via isotope dilution. Special properties: carbon 14 is used in carbon dating. Even fossils' age can be determined by using this technology. Sodium 24, a radioactive isotopes used medically in blood studies, decays by beta decay and has a half-life of 15 hours. Isotopes of cobalt 60, CO60 is used in the treatment of cancer. Isotopes of uranium U-235 is used as a fuel in nuclear reactor. Radioactive iodine I-131, it's used is a treatment of goiter. Phosphorus 32 P32 is used in plant science for tracking a plant's uptake of fertilizer from the roots, leaves, and the decay heat of Pu-238 enables its use as an electricity source in the radioisotopes thermoelectric generators RTGS of some cardiac pacemakers and space satellites, etc. Now, who discovered isotopes? In 1913, while explaining the aspects of radioactivity, Frederick Soddy introduced the concept of isotopes. The first stable isotope in neon was discovered by Thomson. Why do isotopes exist? There may be different types of atoms of a chemical element. These are referred to as isotopes. They have the same number and electrons of protons but different neutron numbers, means same electron and proton numbers, means atomic number, and the different mass number, different neutron numbers. However, isotopes have different mass number because they have different neutron number. Third, what are the natural isotopes? Isotopes are atoms of different masses of the same element. By having different numbers of neutrons in their nuclei, they get these different masses. However, they are the same type of atom because they have the same number of protons in their nuclei. How are isotopes useful? Answer: an element's isotopes all have the same chemical behavior, but the unstable isotopes experience spontaneous decline during which they emit radiation and reach a stable state. The radioisotopes activity is useful for food preservation, archaeological object identification, and medical diagnosis and treatment. Number 5. What is radioisotope? Atoms of the same element are called isotopes with different numbers of neutrons. Many elements contain one or more radioactive isotopes. These are called radioisotopes. Their nuclei are unstable breaking down or declining, and emitting radiation. Now, what are isobars? Now look at the screen. There is the three picture of isobars. It's argon, potassium and calcium. Argon, potassium and calcium are the three different elements. They are different atomic number but the same mass number. So what are isobars? Isobars are atoms of different chemical elements. Isobars, atoms of different elements with different atomic numbers which have the same mass number are known as isobars. Isobars differ in atomic number but have the same mass number. An example of a series of isobars would be 40 argon, air, 40 Cl, 40 air, 40 K and 40 Ca. While the nuclei of this nucleus all contain of 40 nucleons, they contain varying numbers of protons and neutrons. Isobar always have different atomic structure because of the difference in atomic numbers. The number of neutrons makes up the difference in the number of nucleon. Therefore, they are always different chemical elements having same atomic masses. Thus, isobars has different chemical properties. Isobars have similar physical properties. For examples, the isobars iron and nickel. Iron and nickel have atomic number 26 and 28 respectively. However, the mass number is same. This is 50. What are the characteristics of isobars of an element? Isobars of elements have same number of protons and neutrons. Isobars of element have similar physical properties. Isobars of an element have same mass number. Difference between isotopes and isobars. Isobars, chemical elements which have the same mass. Different atomic structure of the same element. Isobars, the atomic masses are equal. Isotopes, the atomic masses are different. Isobars, often the physical properties are similar. Isotopes, usually physical properties are different. Isobars, atomic numbers are different. Isotopes, atomic number are the same. Isobars, chemical elements are different. Isotopes, same chemical elements but in different forms. Now the question answer. Name 3 isotopes of oxygen: 16O, 17O and 18O. How isotopes are formed? Atoms that have an equal number of protons but a different number of neutrons and protons are called isotopes. Give some examples of stable isotopes. Vanadium, carbon, calcium, potassium are stable isotopes. The unstable isotopes emit what rays? Alpha, beta and gamma rays are emitted by unstable isotopes. What are isobars? Atoms which have the same mass number but a different number of protons are called isobars. Give some examples of isobars. 40S, sulfur, argon, calcium, chlorine and potassium. These all are the examples of isobars. Thank you all students for AZIDO education for watching the video carefully, repeatedly, properly. Stay connected for updates. Please don't skip the video. You may miss the tips.